Okay, so the problem, show that a triangle in the complex plane with vertices z1, z2 and z3 is equilateral if and only if z1 squared plus z2 squared plus z3 squared is equal to z1, z2 plus z2, z3 plus z3, z1. Now, this is a rather mysterious problem because at least it's not obvious from the beginning what on earth that means. So I think it is useful to take a simple case as an example to try and see how we might proceed in general. So I'm going to try, first try z1 equals 0, z2 equals 1. And in that case, what we get is 1 plus z3 squared equals 0 plus 0 equals z3, which is a quadratic equation in z3, and when we solve it, we get z3 is equal to 1/2 plus or minus I root 3 over 2. Now, what is that telling us geometrically? Well, here is 0, here is 1, and the 1/2 is saying we're halfway between these, and then we're going either up or down root 3 over 2 to here or here. Now, that's telling me, if you like, that I'm doing something along the perpendicular bisector at this point, which is saying something that this triangle is isosceles, but I'm also choosing the height so that the tangent of that angle, or down here, the tangent of that angle, is equal to root 3, which makes the angle exactly pi on 3 and the triangle equilateral. So, can we generalize this? Can we make this work in more general cases? So what I'm going to do is I'm going to observe that if I've got z1 and z2, and up here I've got z3, then the median of this triangle, which joins the midpoint of this side to this side here, is represented by the complex number z3 minus 1/2 z1 plus z2, while this side of the triangle is represented by z2 minus z1. Now, as argued here, if this triangle is equilateral, then this median has to be perpendicular to this side here, and that means that z3 minus 1/2 z1 plus z2 has to be I times alpha, well, let's make it plus or minus I times alpha, times z2 minus z1, where alpha is real and positive. So this is the condition that says that the median is obtained by multiplying by plus I, by multiplying this line segment by plus I and minus I, and then maybe changing the length. But when I multiply by plus I or minus I make it perpendicular to that segment. So this makes it real and positive, and then to ensure that the length here is root 3 times that length, in other words, to ensure that this angle is pi over 3, so this is the condition for isosceles, and alpha has to be equal to root 3 over 2, and this is the condition for equilateral. Now, that being said, I can rewrite this. Let's first of all multiply through by 2, because there's a 2 there and there's a 2 in the alpha, and square to get rid of the plus or minus 1. This is equivalent to So let's just say triangle equilateral if and only if this, that is the same as saying that 2z3 minus z1 minus z2 squared is equal to 3, that's the root 3 of it, well, the 2's gone because I multiplied by 2, we might square that, 3 z2 minus z1 squared. And if I expand this out, I see that I get minus 3. There was an I there. If I expand this out, then I see that this is equivalent to saying here I will get side, and we will end up with 4 times z1 squared plus z2 squared plus z3 squared minus z1 z2 minus z2 z3 minus z3 z1 equals 0. And this, apart from the factor 4, is exactly the condition